Welcome to Summarize Science. Today we're looking at a fascinating problem in AI. Why can't these super smart models understand simple spatial ideas? For example, they struggle with questions like, is the bowl to the left or right of the laptop? The core issue is what the researchers call the perception reasoning gap. As you can see in this figure, current AI models get much better at answering spatial questions if you give them hints, like drawing boxes around the objects. This proves the AI can reason, but it struggles to connect what it sees with its reasoning abilities. The researchers hypothesized that you can't just teach this all at once. You have to build the skill from the ground up. To do this, they first built a special dataset called SpatialLadder, 26K. This isn't just a random collection of images. It's a complete learning curriculum designed to teach spatial skills systematically. It includes everything from locating a single object to understanding relationships in multi-view images and even videos. The real magic is in their three-stage training framework. Stage 1 is perceptual grounding, which is a fancy way of saying they first teach the AI to simply find and identify objects accurately. Stage 2 is spatial understanding, where the model learns about relationships like distance, size, and orientation. Finally, Stage 3 uses a technique called reinforcement learning to strengthen complex reasoning, rewarding the AI for generating a logical chain of thought to arrive at the correct answer. And the results are seriously impressive. On several spatial reasoning benchmarks, their model, SpatialLadder, achieves state-of-the-art performance. It significantly surpasses its own base model by an average of 23.4% and even outperforms powerful proprietary models like GPT-4o on these specific tasks. Crucially, the model also shows strong generalization, meaning it can apply what it learned to new, unseen problems. So why does this work so well? This figure shows how the trained model learns to focus its visual attention precisely on the objects in question, whereas the base model's attention is scattered all over the image. Furthermore, the model develops a hierarchical reasoning process much like a human would. It observes the scene, reasons through the steps, reflects on its logic, and then reaches a conclusion. So, let's recap the key takeaways. Current AI struggles with spatial tasks not because it can't reason, but because it can't properly ground its reasoning in what it perceives visually. The SpatialLadder approach solves this by creating a progressive training curriculum that first teaches the AI to see, then to understand relationships, and finally to form complex, logical arguments. What does this mean for the future? This breakthrough is essential for real-world applications. Imagine smarter robots that can navigate cluttered rooms, more reliable self-driving cars, and more immersive virtual reality experiences. This research provides a powerful blueprint for building the next generation of spatially aware AI. Thanks for watching Summarize Science.